Hello friends, welcome back to my channels. Today we are going to learn about the new mechanism to control the flow of data is flow control, right? So hope that uh, in my previous video you will understand what is how error has been detected and how those errors have been corrected. So the four different types of error detection methods are LRC, ERC, ERC, and checksum. That is longitudinal redundancy check, vertical redundancy check, cyclic redundancy check, and finally checksums. So, and also we have seen about various kinds of error correction method. In that, we have seen about that is Hamming error correction code, and we have solved a problem also how a single bit has been corrected and how we are correcting the bust errors, right? So now today we will learn about what is flow control, how the data has been controlled from the sender and receiver, and what are all the types of flow control, right? So this flow control is a second layer, that is data link layer, which is mainly responsible for point to point flow of data and control the mechanism of and control the mechanism. All right. So let us see what is flow control. So your flow control is a data frame which we are sending from one computer to another computer over a physical medium or maybe a physical wire or maybe a wireless medium. Okay. So this flow control requires both sender and a receiver, that is host to host communication or peer to peer communication, right? So we both host or maybe a computer uh, should work at the same speed. So for example, if I have a sender with a minimum speed of Core i3 and a 4 GB RAM, means the receiver also it should have Core i3 system with minimum of 4 GB RAM, right? Both the sender and receiver has a network capacity of 100 Mbps connections, right? So we have to choose the hardware in such a way that both systems should have same hardware and software capacity, right? Okay. So in flow control, there are two main types. Okay. One is stop and wait protocol. Another one is sliding window protocols. Okay. So first we will see about what is stop and wait protocols. Assume that this is our one host and this is our another host. Okay. So the flow control mechanism forces the sender after transmitting a data frame to stop and wait until the acknowledgement of the data frame sent is received. So assume that this is our sender and this is our receiver. Initially, a sender sends a single frame, that is frame 0, to the receiver. Okay. So after receiver receives the successfully frame, the receiver send back a acknowledgement, that is the frame 0 has been successfully received. So I have sent the acknowledgement for received frame, right? So then the sender will transmit the next frame. Okay. So again the receiver send back a positive acknowledgement for sender. Similarly, the data will be sent and received for positive transmissions. Okay. So what is the advantage? So the advantage is no negative frame will be transmitted. Okay. Suppose for example, if a sender sends the frame 0 to the receiver, during transmission time, if the frame is not received at the receiver side, the receiver will transmitted a negative acknowledgement. Or suppose this receiver doesn't send back a acknowledgement, means the sender has to wait until it receives a acknowledgement. Okay. So hope you understand, students, right? So then what is the main drawback? So each and every frame the sender has to wait. That is the main drawback is waiting time. So the distance to travel from sender to receiver, the same the receiver to sender, the sender has to wait. So if you check the time for send and receive will be more. Okay, the sender and receiver will take same time for sending the data from sender to receiver, and the sender has to wait until a positive acknowledgement receives from the receiver. Okay, so here the main drawback is the waiting time. Okay, so for this reason we are moving to a new concept called sliding window, right? So in sliding window, the control mechanism, both sender and receiver agrees on the number of data frames after which the acknowledgement should be sent. As we learn stop and wait flow control mechanism, so this protocol tries to make use of underlying resources as much as possible. Okay, so in sliding window, several frames will be transmitted from the sender and waiting for a single acknowledgement. Let us see how. Okay, so in sliding window, first we have a error control. Okay, so how we are controlling the error. Okay, so in when the data frame is transmitted, so there may be a probably data may be a lost during transit or received side, or it may be a corrupted bits. Okay, in both cases the receiver does not receive the correct data frame, so and sender does not know anything about any loss. Okay, in such cases both sender and receiver are equipped with some protocols which helps them to detect the transmit errors. Okay, so such loss of data frame we are seeing as a error control. Okay, so required uh, the requirement for error control mechanism is, so we have error detections, positive acknowledgement, negative acknowledgement, and retransmission of negative frames. Okay, so let us see. So first we will see about stop and wait protocol, right? First we will see about stop and wait protocols. Okay, so this method is mainly used to implement the automatic repeat request. Okay, so in this case, that is in stop and wait protocols, each frame after successfully transmitted from the sender, the receiver should the receiver will send back a positive acknowledgement to the sender. So therefore, the sender has to wait for the positive acknowledgement. So in this case, a automatic repeat request protocol is used to receive a positive acknowledgement. Let us see how. Okay. So a stop and wait ARQ, that is stop and wait automatic repeat request. If you see the diagram, I hope you will understand clearly. So initially a frame 0 is sent to the receiver. Okay. So meanwhile, it wait for a acknowledgement. Okay. So uh, the sender is equipped with a timer. Okay, when the timer is over, again the sender will transmitted the data, that is the next frame will be transmitted. Okay, and equipped with a timer. If your time is over, automatically the next frame will be transmitted. Okay, so in the meanwhile the receiver will send back a positive acknowledgement to the sender. Okay, so if the acknowledgement, if the sender is received a negative acknowledgement from the receiver, the sender will retransmit the particular frame, that is particular error frame. Okay, so if you see here, so initially we are transmitting a frame 0. Okay, so the sender will wait for an acknowledgement. If you see here, the sender will receive a positive acknowledgement. Also we have a time sequence. Okay, If the time is over, automatically the next frame will be transmitted. Okay, now we have transmitted frame 0 and frame 1. Okay, see here, the frame 1 has received at the receiver side, but the receiver has not uh, transmitted a positive acknowledgement. Here the time is again over. Okay, see the waiting time, the waiting time is over. What the sender assumes, the sender will assumes that the particular frame one has been error or maybe a corrupted during transmissions. So the sender will assume that the frame one has been corrupted, it has to retransmitted again. So therefore this frame one will be retransmitted again from the sender side. So again the receiver, this time the receiver send back a positive acknowledgement. So this method continues for all until your data has been successfully transmitted from the sender and receiver side, right? Okay, next we will see about go back NRQ. Okay, so what is go back NRQ? In stop and wait, ARQ mechanism does not utilize the resources at their best. If you see here, so again here it has to wait for the positive acknowledgement frame. It doesn't so therefore we need a more time for sending and receiving data without error. Okay, so we have to wait more time from the sender side also and the receiver side also. Okay, so it doesn't utilizes all the hardware equipment. Okay, all the mechanisms. So therefore we are using a new concept called go back NRQ, go back n automatic repeat request. Okay, so here we are sending a multiple frames. Okay, here we are sending a multiple frames. It doesn't require a timer. Okay, it does not require a timer. So here we are sending a frame 0, frame 1, frame 2, frame 3 and frame 4. That is 5 frame we are transmitted with the help of a timer. Okay, with the help of a equipped timer, but here the timer will not wait for a positive acknowledgement. Okay, initially it transmitted 5 frames simultaneously. Okay, within the given time. Okay, frame 0, frame 1, frame 2, frame 3 and frame 4. That is 5 frames we have been transmitted from the sender. The receiver will send back only a positive acknowledgement of the particular frame. If you see here, so frame 0 which is received at the receiver side, frame 1 also received at the receiver side, frame 2 also received at the receiver side, frame 3 also received at the receiver side, frame 4 also received at the receiver side. But we received only a positive acknowledgement of first 2 frame alone, that is frame 0 and frame 1 at the sender side. Okay, so therefore what will this go back NRQ will do is, so the frame 0 and frame 1, okay, only we receive a acknowledgement for first 2 frames. So the frame 2, frame 3 and frame 4 will be automatically discarded. The receiver, what the receiver sends only for the first 2 frame alone. Okay, so therefore the receiver will do frame 2, frame 3 and frame 4 will automatically discarded at the receiver side. Okay, therefore the sender will be retransmitted for frame 2, frame 3 and frame 4. So if you see here, frame 2, frame 3 and frame 4 will be retransmitted at the sender side. So on the receiving side, this time we'll receive a acknowledgement for the frame 2, frame 3 and frame 4. Okay, hope you understand, students. Okay, now here the main advantage is several frames we have been transmitted from the sender to receiver, but though the frame 2, frame 3 and frame 4 will be received at the receiver side, we again this mechanism will take place there, again retransmission of received frame. Okay, so here if you see 2, 3, 4 is received at the receiver side, but again here we get retransmission of frames because of we doesn't receive a acknowledgement for 2, 3 and 4. Okay, so the sender will retransmit those bits again and again. Okay, so that is the main drawback of go back NRQ. Okay, so here selective repeat ARQ. So for this reason we are moving to a new concept called selective repeat ARQ. Okay, so here in selective repeat ARQ, the same mechanism what we have used in go back NRQ will be used. Okay, if you see here, frame 1, sorry, frame 0, frame 1, frame 2, frame 3 and frame 4 will be transmitted to the receiver side. Again here we receive only for first two frame alone. We receive a acknowledgement for first two frame alone. We have not received for third frame. That is, we have not received for frame 2. Okay, so the frame 2 acknowledgement is discarded. So meanwhile frame 3 and frame 4 will received at the receiver side. So the receiver what will do, the acknowledgement of for third frame and fourth frame will be transmitted at the sender side. Once the all the frames, that is first all the 5 frames has been received on the receiver side, the sender will retransmit only the particular damaged frame. Okay, if you see here, frame 2, frame 5, frame 6. So for frame 2 we have not received the package. Okay, for frame 5 and frame 6 we receive a acknowledgement. Only the frame 2 will be retransmitted again. Okay, so here only the second frame alone will be retransmitted. Right, I hope you understand, students. Again I'm repeating this concept because it is somewhat complicated to understand. So in go back NRQ, in go back NRQ, we are transmitting several frames. That is, first we are transmitting 5 frames. So we are waiting for an acknowledgement. So for frame 0 and 1, we receive the acknowledgement here. For frame 2, that is the third frame, we have not received the acknowledgement. The sender will discard, sorry, the receiver will discard at the third frame, fourth frame. Okay, also the second frame. So because of we have not received the acknowledgement, even though the frame 2, frame 3 and frame 4 is received, successfully received on the receiver side, because of the negative acknowledgement, sorry, because of the negative acknowledgement, the sender will retransmit the second frame, third frame and fourth frame until the sender receives a positive acknowledgement from the receiver. Okay, for this reason we are moving a new concept called selective repeat ARQ. Selective repeat ARQ. So in this method, again we are transmitting several frames. So I'm going to enlarge somewhat. Okay, so okay, in selective repeat ARQ, so again we are sending several frames. That is, first frame, second frame, third frame, fourth frame, fifth frame. Again, I have transmitted 5 frames simultaneously and waiting for an acknowledgement. Here, the sender will received for first frame, second frame. Okay, but not the third frame. Okay, so meanwhile it receives the acknowledgement for fourth frame and fifth frame, that is the acknowledgement for third frame and fourth frame. Okay, so once all the frames has been received successfully, so that is once all the acknowledgement received from the successfully, the sender will retransmitted the particular damaged frame. Here the frame 2 has been damaged since we are not receiving the acknowledgement. So the sender will retransmitted the particular frame alone. Okay. So this is the main advantages of selective repeat ARQ. Okay. So again the frame 5, frame 6 which will goes goes on. Okay, so here frame 5 and frame 6. So if you see here, frame 5 we receive a acknowledgement, for frame 6 we receive a acknowledgement, right? So hope you understand, students. If you have any doubt or any questions regarding this uh, error control mechanism, feel free to comment on my YouTube channel, or you can contact me on WhatsApp. Okay, thank you.